So there's the test outline of what it will look like on Thursday. And I've got ones circled but I hadn't looked at the test yet, so I don't even know that. It's not like they're test inspired. I just picked ones that sort of covered everything. So if you have questions from the review, ask them. If you don't have questions, then I will pick some for us to go over. So have you looked at the review to even know what to ask?
Kind of. Could we go over number 12, the multiple part with the left ream and sum?
Yep. So perfect. That's one that I had circled.
Because I can't remember how to do a ream and sum.
Sure. Number 12. A tank has a height of 10 feet. The area of the horizontal cross-section of the tank at height h is given by the function a, where a is measured in square feet. The function a is continuous and decreases as h increases. So I have no idea what this shape looks like, so it's not a circle, but I'm just trying to draw something where the cross-sections are getting smaller as we increase our height.
Volcano, yeah.
So who knows? I don't really know. We just know what, the cross-section down at the bottom is 50.3, and then at 2 feet up, it may not even be a circle, but that cross-section is 14.4, and then at 5 feet up, 6.5, and then all the way at the top, that area is 2.9. You don't need to draw that out, but maybe that helps visualize and see what they're trying to tell us here. Use a left Riemann sum with 3 subintervals. Okay, that makes sense because I've got 4 pieces of data, which makes 3 intervals, to approximate the volume of the tank. Okay, well, volume, especially if we have cross sections, is adding up the cross sections dy. Actually, we could just call that dh from 0 to 10. But I don't have a function that I can plug in there. So I kind of have to do it by hand, and I have to approximate. So a left hand, so I need a times the change in h. So I'm going to do, and a left hand means use the left hand height. So I'm going to approximate that. So the first height is not the first height, the first area is 50.3
Times 0?
times 2, the width of that interval. And for our picture, well, left means use the left values. So I'm going to use,
Okay.
I don't know if that's helpful or makes it more crazy. I'm going to find the area of that cylinder, because that's as good as I can get for approximating the area of the cone. So 50.3 times 2 plus 14.4 times 3 plus 6.5 times whatever that last height is, which is 5. Yeah.
Change in height.
Yes, the change in height. And that's a safe stop, so you could leave that. Even on a calculator test, you can leave that.
But it says indicates unit of measure.
Thank you. Oh, this person isn't in here.
Oh.
This is unit 4113.
Oh, you're right. Thank you.
You're welcome. Indicate units of measure. So I still don't need to. I need units. You're right, but I don't need to simplify that down.
Oh, okay.
Indicate units of measure.
Feet
cubed, because it's volume, so it's got to be cubed. But if you want to sort of figure that out, the area is feet squared and the height is feet. So feet squared times feet is feet cubed. I don't know that you really need parentheses around all of that. I mean, it's pretty clear that feet cubed goes to everything. Part B. I think I've answered Part B with my superb artistic skills. Does the approximation in Part A underestimate or overestimate the volume of the tank? Over. Now we need a reason other than I drew a really cool picture that makes me able to see.
Because since there's an inverse relationship between area and height.
Yeah, let's do better than. I mean, that's right, but I want to say, what did they tell me that would help me to know that? They said area is continuous and decreases. So integral of a decreasing function with left sums. Might have been better if we'd have drawn it this way. There we can see it. If we do a left-hand area, that's going to overestimate. So your answer would probably have to say decreasing function with left-hand sums. That would be the words they'd be looking for there. If you said that a different way, like inverse relationship, maybe you'd still need to say left-hand sums, Luna, if you said an inverse
I
relationship.
just didn't finish my thought there.
Yeah, I cut you off.
You said and no.
All right, part C. The area in square feet of the horizontal cross-section is modeled by this function.
Yeah.
Based on this model, find the volume of the tank. Well, it's still this volume is still integral of the areas times dH. So they told me that this is the area, so I'll put this in for A. I don't even have to write that, actually. I can just put f of h dH. What about my limits from where to where?
0 to 10.
0 to 10. And that's a calculator problem now. 0 to 10. I can't just put f in my calculator because my calculator doesn't know what f is.
Just type in that into y equals.
So I could do y equals. Since I'm only using it once, I'm going to go ahead and just type it in. But we'll see. Although, I'm looking ahead. Part D says using the model from Part C, so maybe I should put it in for y1. Because I might need it again. .2x plus x. I'm not even going to graph it because I don't care what it looks like. It's probably weird. I don't want to mess with that. So math 9, 0 to 10. Now I can use y1 dx. That was kind of a hard one. 101.325. It would maybe be interesting to see how that compared to our answer from Part A, but I didn't really get a number for Part A, so I don't know. Indicate units of measure. Okay, feet cubed because it's volume. And because it was feet squared times feet, so feet cubed. All right, Part D. Again, multiple or free response questions on the AP test, worth 9 points, all of them. This was actually one that they've done previously, so that means there is a way to get 9 points out of this. My guess is 2 for Part B, probably just the answer and the reason. Probably 2 for Part A because it was kind of easy. Maybe 2 for Part C because that was pretty straightforward. Maybe 3 for Part D. And the only reason I'm guessing on that is to show that I would hope you could get Part A through C right. Part D, We'll see. But if you get part A through C, you got 6 out of 9. That's a 4, maybe a 5. Like you're doing fine on the AP test if you get 6 out of 9. So obviously go for every point you can get, but especially on the free response ones, there's usually one piece of the free response where it's like, ooh, let me give it a go and see what happens. But you're just hunting for points at that point. So let's try D, but realize that if that one looks hard and you think there's no way I get D, that's okay. If you can figure out A, B, and C, you'd still be fine. All right, water is pumped into the tank. When the height of the water is 5 feet, the height is increasing at the rate of 0.26 feet per minute. Okay, so when h equals 5, the dt is 0.26. Using the model from part C, find the rate at which the volume of water is changing with respect to time when the water is at 5 feet high. So what is it asking me to find in terms of
dv dt?
Yeah, dv dt.
Which we've done before, I just can't remember how.
At h equals 5. Okay. I don't know that alone would be enough to get you 1 point, but it might. Sometimes they give you a point for like recognizing that, hey, we gave you dHdt. Did you know that's what we gave you? And so maybe that's worth the point.
For interpreting.
For like being able to understand the calculus to English translation there. All right, so I need an expression for V,
Isn't it V equals 1/3?
which I have no, because I don't know that it's a cylinder. My V is this integral from 0 to, I don't know, V of H. I don't like using H twice.
B.
B. So 0 to B, F of B, H. No, that's not right either. F of H, dH. Oh, I know where this problem's going.
Is it the VB equals...
So I want to take the derivative of both sides.
Yeah.
So that I'll have dV dH on the left. And what is happening on the right?
F of B minus F of 0.
That would be no, not yet.
It undoes the integral.
Right, it undoes the integral. The derivative undoes the integral. The derivative undoes the antiderivative.
Yeah.
And so we're right back to F of, plug in the top number, F of B. Yeah, I think that's right. And so dV dt at t equals 5, or excuse me, at h equals 5, dV dH at h equals 5 is f of 5. Wait a minute.
Equals F of 5.
Wait, something's not right here. Because it said dV dt.
For a minute, yeah.
Okay, I knew something wasn't right about that. So dV dt, the derivative and the antiderivative undo each other, but the letters are not the same.
Yeah. So you have to...
So dH dt. That's also why they gave me dH dt. So it's f of 5 times 0.26. Let's see, f of 5 would be 50.3 e to the 0.2 times 5.
Or you could just go into your calculator.
I could go into my calculator. Times 0.26. Indicate units of measure. F of 5 is area. Oh, hold on, back up. Units of measure for dV dt should be feet cubed per whatever time we're using, minute. But I'm gonna get it a different way and see if I get feet cubed per minute as a check here. So f of 5 is an area, that's feet squared. 0.26 was feet per minute. And so yeah, feet squared times feet per minute is feet cubed per minute. So now I feel much better about my answer than I did when I mixed up the H and the T there. And yeah, that's a safe stop, although most people want to know, well, what's the answer?
Well, if you go into,
I don't know what the answer is.
if you go into graph, you can get the value and then type in the y, and then multiply that by 0.26.
That's true. You can also do that on the main screen, y1 of 5, like that, and then times 0.26.
Yeah, that's the answer I got.
1.694. Little side note, do you remember how many minutes per problem you get on the free response section?
3?
No, in the free response section.
15.
You get 15.
I got it right.
And our clock now is at 16:30.
And there
But
was a
that's
little bit of
'cause
chatting and
That's a
explaining.
little bit of chatting and explaining and me talking, and so
And you
yeah,
also-
we've been okay.
You also included like the going over the test.
And the test outline was there, and I even messed up something and had to fix it. So they try to give you enough time. They really don't. I mean, it becomes a time crunch because there's stuff you don't know, but it's not a time crunch. Like if you knew
Because they
everything.
don't give you enough.
Yeah, it's not a time crunch. They don't give you enough time. It's a time crunch because there's gaps in your knowledge. Because there isn't everybody. Because it's a hard topic, and yeah. But that's just to say, if you get stuck somewhere, don't. I mean, you know this on a
Don't
timed
panic.
test. Don't panic. Don't spend 10 minutes spinning your wheels on the last part of a really hard problem. Like, just put a star on it and move on. Maybe you could figure out units of measure and get a free point out of that. That'd be nice. Maybe get 7 out of 9 without having to do the worst part of the problem. Okay, so that was a little bit of a review of Riemann sums, of fundamental theorem of calculus, where you undo a derivative and an antiderivative, cross-sectional areas. So I had 10 circled, but yeah, I'd rather do 10. Let's do 10.
Because you told us to.
Did I do 10?
No, you did
You
11.
told us to like try it.
I did 11.
Yeah, I said you do 10.
Tell you what, why don't you take
Oh
some
no, I
time?
tried 10.
You take some time to do 10. And I'm thinking A should be relatively easy. B is maybe tricky. C you should get. And D is definitely tricky. So A and C you should get. B I think you can get if you just think about what it means, vertical distance from F to G. If you write an equation for that, it's not really that hard. And then D is kind of tricky. So do A and C for sure. Try B, and then if you get time, try D. It helps us set our window so we know what we're looking for. We're not crazy searching for something weird. So natural log x plus 3 and x to the 4th plus 2x cubed. And that looks funny because my window is weird. So I'll go -2 to 2 and -2 to 2. Close enough. And that should look like the picture they give me. Okay, so I'm on the right track. I've got these in my calculator, so I'm even going to say y1 equals f and y2 equals g. That way if I mess up, it's not really messing up. If I inadvertently say y1 or y2 when I probably should say f or g, I'll still be okay because I've told the grader when I say y1, I'm talking about f. All right, find the area of the region enclosed by the graphs of f and g. So I figured out which one's top and which one's bottom. So I'll integrate top minus bottom dx, and from -2 to whatever b is. So b equals intersection of f and g. So second calc, intersect, first curve, second curve, guess, let's get over here, 0.78197. When you put the ... that means that you know there's more, you're just storing it in your calculator. You don't even have to tell them you're storing it, it just means, hey, I know there's more there. So store that as b. And so now I'm ready to -2 to b of f minus g dx. I think I grabbed the calculator that doesn't have the...
Just hit back 9 real quick and you'll do it. Yep.
Alright, so I'm going to do this the old-fashioned way. y1 minus y2 with respect to x from -2 to b. I should probably just get a better calculator because your calculators aren't going to look like that. 3.603, is that what y'all got?
3.604.
3.604, yes. 3.604. So I'm going to switch to a calculator that'll at least look pretty for me. Natural log x plus 3. Okay, there we go. Better. Part B. Between -2 and b, let h of x be the vertical distance between f and g. So that's what it's talking about, is just f minus g. So h of x equals f of x minus g of x. Is h increasing or decreasing? So that sounds like slope of h stuff to me. So I want h prime at -0.5. Well, the derivative of h is the derivative of f minus the derivative of g. So, that's probably the most straightforward way to do it. You could, in your calculator, put in an h function and make it y1 minus y2 and have your calculator find the derivative of y1 minus y2. I don't know. I suspect most people just found the derivative of the pieces. Math 8. So I want the derivative of y1 at -0.5. And heck, I may as well just do the whole thing. Minus the derivative of y2 at -0.5. So that's -0.6. So h of x is decreasing. Okay, part C. The region enclosed by the graphs of f and g is the base of a solid. Cross sections of the solid are taken perpendicular to the x-axis. So I know I'm going dx here. Find the volume of the solid. So from -2 to b of the area of a square The area of a square is side squared. And the side length would be f minus g, which I could just use h since they already talked about h, but I probably would go with f minus g there. Math 9, negative 2 to b. Oh, careful with parentheses. y1 minus y2 squared dx. 4.623. Yes, anybody else get that? Okay. And then part D. A vertical line in the xy plane travels from left to right along the base of the solid, described in part C. The vertical line is moving at a constant rate of 7 units per second. So something dt is 7 per second. Find the rate of change of the area of the cross section. Above the vertical line with respect to time when x equals negative 0.5. So dx dt is 7, the ADT is what we're looking for. So that area is, this is related to part C. That area is f minus g squared. If I want dA dt, this is maybe tricky. I need a derivative. dA dt equals d dt of f minus g squared. But I'd really like a calculator to do this. I don't want to do this by hand. The trick is f and g have x in them. So it would have been better if I'd have gone with h here. 2 times f prime of g, f prime of x minus g prime of x times dx dt. That's the key part they want us to see, is that sort of chain rule thing. dx dt, that's where the 7 will go. Wait, that's not right either. This is why I should have done it in the calculator. I'm going to let h be f minus g. And then, so dA dt is dH dt, or dH dx times dx dt. So dH dx I can get from the calculator. Dx dt is 7, and I can go from there. Yeah. Again, part